ඉස්සරහට යන්න ඉස්සෙල්ලාම චුට්ටක් කියන්න මේ ලැන්ග්වේජ් එක ගැන චුට්ටක් කතා කරලා ඉන්නම්. මොකද මේ සිංහල වලින් ඔයගලන්ට එක්ස්ප්ලනේෂන් එකක් මම දෙන්නම් අවශ්‍ය කරන තැන්වලදී. නමුත් මම හිතනවා ඉංග්‍රීසි වලින් ඔයගලන්ට කියන දේ තේරුම් ගන්න පුළුවන්. ඔයගලට ඉංග්‍රීසි කියන එක පොඩ්ඩක් අර මේ ඔයගලන්ට අමාරුයි වගේ වෙලා තියෙන ඔයගලන්ට ටෙක්නිකල් ටර්ම්ස් ටික නේ. මොකද මම වගේ මම මාත් කරේ සිංහල මීඩියම් එකේ ඉනවනේ. එතකොට යුනිවර්සිටි එකට එනකොට ඔයගලන්ට ඒ තියෙන ටර්ම්ස් ටික මැතමැටිකල් ටර්ම්ස් ටිකම බේසික්ම ටර්ම්ස් පවා ගොඩක් දෙනෙක්ට දන්නේ නැහැ. එතකොට පොඩ්ඩක් එතන ස්විච් වෙන එකේ පොඩි ප්‍රශ්නයක් එනවා. ඉතින් ඒක තමයි අමාරු. ඒක නිසා මම මේ කියන්නේ ඔයගලන්ට මම හිතන් ඉන්නේ ඉංග්‍රීසියෙන් කන්ඩක්ට් කරලා යන ගමන් මම මේ සිංහල ටර්ම්ස් එක උදාහරණයක් විදිහට අපි ගත්තොත් දැන් හරය ලැබේ වගේ මොකක් හරි આવත් ඒකට කියන ඉංග්‍රීසි ටර්ම් එක ඒකම සිංහල ටර්ම් එකත් එක්කම කියන්නේ. මොකද සිංහල මීඩියම් කරපු ළමයෙක්ට තේරෙනවා මොකද්ද මේ කියන්නේ කියලා. ඒතර ඔයගලන්ට ඉංග්‍රීසි මීඩියම් කරනවා කිව්වම ගොඩක් තේරුම් ගන්න අමාරු වෙන්නේ නැත්නම් ඉංග්‍රීසි බැරි කමක් නෙමෙයි තියෙන්නේ. ඒ ටෙක්නිකල් ටර්ම්ස් ටික ඔයගොල්ලෝ දන්නේ නැති නිසා. නිසා ඒ ටෙක්නිකල් ටර්ම්ස් ටික මම සිංහලෙන්ුත් කියනවා. සිංහලෙන් කරපු කෙනෙක් ඉන්නවනම් මෙතන ඒගොල්ලෝ ඉංග්‍රීසි මීඩියම් ඒ ටික පුළුවන් කරගන්න. මම හිතනවා අනිත් අතින් නම් මම හිතන්නේ ඉංග්‍රීසි වලින් සාමාන්‍යයෙන් දෙයක් කිව්වම මෙතන ඕනම කෙනෙක්ට ඒක තේරුම් ගන්න පුළුවන් සාමාන්‍ය ඉංග්‍රීසි. මම කතා කරන්නේ මේ ටෙක්නිකල් ටර්ම්ස් කියන නෙමෙයි සාමාන්‍ය ඉංග්‍රීසි. ඉතින් ඒක නිසා මම පොඩ්ඩක් ඉංග්‍රීසියෙන් කියන කැමති. මොකද මම ඊයේත් මට දෙතුන් දෙනෙක් මෙසේජ් දාලා තිබ්බා. මොකද දැන් මෙතන ඉන්න ගොඩක් දෙනෙක් ඉංග්‍රීසි කරොත් ඒක ගොඩ දෙනෙක්ට ඒක පැමිණිය වෙන්න පුළුවන්. හැබැයි මේ තේරෙච්ච නැති කිසිම දෙයක් තියෙනවා. ඕනම වෙලාවක chat එකකින් හරි WhatsApp එකෙන් හරි මෙසේජ් එකක් දාලා අහන්න අනිවාර්යයෙන්ම. මම ඒකයි සිංහල එක්ස්ප්ලেইন කරන්න. ඒ කියන්නේ සමහර තැන්වල මම එක්ස්ප්ලেইন කරද්දි සිංහලනුත් කියන්නම්. මොකද විශේෂම තැන්වල. නමුත් ඕවරෝල් මම ඉංග්‍රීසි වලින් පොඩ්ඩක් කරගෙන යන්නම්. මොකද අර ටර්ම්ස් ටිකත් ඉංග්‍රීසි වලින් තියෙන නිසා වැඩේ ලේසි. කරන් යන්න. හැබැයි මම ඒකට අවශ්‍ය සිංහල ටර්ම්ස් ටිකත් ඔයගලන්ට කියන්නම්. Hi. So before you're gonna start today, actually, we have a couple of I have like some more announcement to do. Actually, this is a totally free of charge session series for you guys because I was also like a professor like you, so I know there's some pretty much like stress and also competition in first semester examination. So you are trying to achieve good results in first semester in order to to go to a good field. It is actually 21 people knows that, and also I think after 12 people might or might not know that. So I think that's why you need to learn the bit stuff early. It is basically this is not a tuition class anyway. This is not a class or this is not a lecture. This is a kind of helpful session done by some senior guy or some ayya to some Malilas and Nagilas. So you don't have to call me sir. So you can just say my ayya or my name. That's the how it goes. So then actually at the start I say that there are a couple of people to help you other than me. So there are one people Samit Mal is there. It is from 19 batch. I think for 21 batch it is I think 2 years senior to you and for me actually 2 years junior to me. But there are a lot of people to help you guys in the upcoming sessions. So the plan is this. So actually initially we are like this week actually I'm gonna cover up some basic fundamental in mathematics, and next week you're gonna learn something more fundamentals or like something in programming, and we have to sit between in these weeks, and we are trying to like conduct in like it is around 2 to 3 months, so then you can have a better understanding on this concept and it will be helpful to you all. Because in nowadays there are things called specs cookies, but sadly those things are not there much. That thing. So due to these pandemics and online education, online things and so on. So, so before going to my mathematics part, I will. The main plan is like, as I said, like it is every other week. It means kasatiya kena satya. Single kena. It means we conduct 1 week we conduct mathematics and 1 week we conduct programming, and also as the season progresses, actually there are some people want to do electrical stuff too and mechanical stuff too, so we can arrange another day if we want, and if you guys are prefer to it, and then you can cover all the subjects because there are a lot of people going to be yeah, ISMS exam is planned to conduct in December. So before December, I think we can cover a lot of to you. This is anyway, it is not going to be lectures. I only advise you to attend the lectures, but take this as an opportunity to learn the stuffs you find difficult and the second chance to learn. And also, if you have any other specific thing to be covered, let me know, so then I can contact few of your my colleagues and also my university friends and juniors as well. So they are willing to help you. There are a lot of people to help you. So this is a little initiative. So I think in the when this is progress, it is a bit much good help for you. So I think before going to my mathematician, I will invite Samit Malli to do a. I invite him to today to attend, and I thank you, thanking him to attending this also. So I invite him to like briefly present about like programming style and what is his plan, and so then you can actually get this knowledge as well. So then you are, because those are the two modules. Because I decided to start with programming one because these are the most two of the most important modules in the first semester, three credit modules. So don't yeah, they are OS student as well. Okay, so you can learn anyway. That's good, right? It is no age cap. So having said the engineering thing, because these are mainly intent for that one, but if you are anyone interested, anyone can join because it's a free thing. Anyone can join. So that's okay. So I will invite Chamit Malli to give some brief introduction in the programming sessions, and if you, I think it is better if you can share some experience in university life as well. So because there are not experience, I think university exams. So then I can share my experience after you. So Chamit Malli. So
Yeah. Can you hear me? Am I clear enough?
yeah.
Yeah. Okay. Great. Thank you, Sadashanaya, for giving me this opportunity to talk with this. Generation. I'll share my screen. Tell me whether is it visible? Clear?
Yeah, this way.
Great. So what I'm gonna do this is to give you guys the understanding on basic things about Python programming language. So today I'm gonna look minutes like for 10 minutes to talk about the introduction section of Python. So graduate from the University of Montreal. මම කටියට අද Python ගැන පොඩි ඉන්ට්‍රොඩක්ෂන් එකක් දෙන්න විනාඩි 5ක 10ක. ඊළඟ සතියේදී මම සදෂන් මගේ කියපු විදිහට අපි මේක කරගෙන යමු. So what is the programming language? I think that you guys have heard the term programming language.
Chamit, I think your voice is breaking. So if you can share the camera link too, I can share it.
Is my voice breaking?
Yeah, I think it should be due to the like screen sharing thing, because I think your wireless is not speed enough. So you can share. You can share the camera link to me, so I can share it.
Yes,
So
I sent you the link to WhatsApp.
okay. Wait a minute, will I share the screen? Oh. Yeah, now you can go ahead.
Okay. Please tell me if my voice is still breaking. I hope you know I'm clear. Krishna, can you confirm?
Yeah, now it is okay, so you can go ahead. If it is breaking, I'll let you know.
Okay. Can you move into the next slide, Daya?
Is this
Yeah. Yeah. This is where we were. So, what is the programming language? So, you may have heard about the term programming language, but how many guys actually know the meaning of a programming language? So, it's like this. Can you go to the next slide, David? Can we talk with machines, right? As you see in the cartoons, there will be like machines that can talk, computers that can talk, washing machines that can talk. But in the real life, is that the situation? No, it's not, right? So as people, we cannot talk with machines. But the thing is, the machine communicate different language and we communicate in a different language. For an example, if I am a person who only knows Sinhala language, and if there's another person who only knows English language, I can't communicate with him because there is no common language in between us. මම සිංහල කතා කරන කෙනෙක් නම් තව කෙනෙක් ඉන්නවනම් ඉංග්‍රීසි විතරක් කතා කරන්නේ මම සිංහල විතරයි නම් කතා කරන්නේ මට යත් එක කතා කරන්න පොදු ලැන්ග්වේජ් එකක් නැහැ. So that's where we use programming language. Can you move into the next slide, David? As we know, in ancient days, we used like birds to send messages, right? So අපි ඒ දවස්වල අර කුරුල්ලෝ පාවිච්චි කරන්නේ messages එවන්නේ. ඒ වගේ programming language එකක් කියලා කියන්නේ අපි machine එකයි අතර bridge එකක් හදන්න පාවිච්චි කරන අපි machine එකයි අපි තව මොකක් හරි machine එකයි අතර communicate කරන්න path එකක් හදන්න අපිට පාවිච්චි කරන්න පුළුවන් language එකක්. So there are few different programming languages. In the next slide, you can see what are the programming languages that are available in the world. So Python, C, C++, C#, Java, and many programming languages are there. But starting with Python is a good step for you guys. Can you move to the next slide? So what we can do with Python, we can use Python to develop websites. We can use Python to develop software. We can use Python to develop applications in artificial intelligence. අපිට Python පාවිච්චි කරන්න පුළුවන් software හදන්න, website හදන්න, ඒ වගේම කෘත්‍රිම බුද්ධිය, machine learning සහ machine learning and artificial intelligence. කෘත්‍රිම බුද්ධිය. මේ දේවල් එක ගනුදෙනු කරන්න Python කියන්නේ ගොඩක් හොඳ tool එකක්. අවම ඔය කට්ටියට අවබෝධයක් නැතුව ඇති අපි මේ දේවල් කොහොමද කරන්නේ කියන එක ගැන. I'm not going to teach you guys about software development or web development or artificial intelligence through this code, but what I'm going to do is to give you guys a basic understand about Python, and then on top of that you guys can do own part and learn. මම ඔය කට්ටියට Python ගැන basic අවබෝධයක් Python වල basic දේවල් ටික ඔයාලට කියලා දෙනවා. එතන මත පදනම් වෙලා එතනින් එහාට ගිහිල්ලා ඔය කට්ටියට පුළුවන් වෙනවා ලියසින් මේ Python ඉගෙන ගන්නවා කියලා. එතනින් එහාට අපි මේ කතා කරපු software development, web development සහ artificial intelligence මේ සම්බන්ධ පැතිවලට ඔයාලට යන්න පුළුවන් වෙනවා. Can you move into the next slide? So why this Python programming languages is more important to the students in University of Morocco? That's because in the first semester you have to sit for the programming fundamentals module, and in that module you may cover the basic stuff about programming, and as the programming language to go through that course, the university has to choose Python. For the first semester the programming fundamentals කියලා dedicated module එකක් හම්බ වෙනවා. ඒකෙදි අපි කැම්පස් එක තීරණය කරලා තියෙනවා ඒක කියන programming language එකත් එක්ක ඔකට ඉතින් ඒකින්ද ඔකට Python ගැන හොඳ අවබෝධයක් තියෙන එක ඒකට ඒ first semester result එකට ලොකු බලපෑමක් ඇති වෙනවා. Can you move to the final slide diagram? So that's what I wanted to cover in this introductory session, just about what is Python and what we can do from Python, why do we want to learn Python, and I'll send you guys a video clip about installing how to install Python to your computer or your mobile phone to the WhatsApp group for Pakistan Maya. By the way, if you guys have any questions, please feel free to drop me an email, or otherwise you can ask it in the group as well. I'm done, sir. Okay. And, thank you for attending, and also thank you for giving me this valuable question.
Okay, so thank you, Tamitmal. I think it is like very good introduction. I think it is always better to learn why you learn these things. That's why I invite him to learn, because the programming stuff. I think there are, I know 21 people know some sort of Python knowledge up to now, but the newcomers should be why we learn this. Also, it is important to 21 people to learn why we learn these things. So I think that is the one reason that you find the most subjects difficult, especially in mathematics and real analysis. You don't know why the hell you are learning it. So then I think we can start go ahead with the mathematics. So if you have any clarifications to regarding with Python, I think you can contact Shamitaya in upcoming sessions, and I will ask him to share his contact details with you so that you can directly contact him. Okay, so now today, I think Shamit Mali, now you can leave. And if you have any problem for Chamitaye, so you can put a message in WhatsApp group. So he's in WhatsApp group and Telegram group. As I know, I think I added him to Telegram group. But in WhatsApp group, one WhatsApp group, he's not there. So you can put a message. I will forward to him if that is the case. So yeah. So now we can go into the analysis section. I will thank him again for the Chamit Mali accepting the invitation as well. So give me a minute to share my screen. Let me know, do you guys get my whiteboard? Because otherwise, it's going to be a. Currently, I'm following a Python course in Coursera. Is it enough for first term exam? So I think let's leave it. So I will answer that question. So it is enough to learn you the basics of the first semester, but in order to do the labs, and there are two programming problems for you guys to do, PP1 and PP2. So I think you need to do something in Projective Lab as well as HackerRank. So I will share the details in the WhatsApp group, so you can easily go to that, find and do their exercises and get good at that sort of problem. Because especially in HackerRank, because the programming problems that you get are equal to the programming problems in the HackerRank. So that's the thing you need to practice. Okay, so today, so let's go into today Ninja mathematics session, because that's the main part of the today's thing. So I will start with the real analysis. Okay. So first of I think 21 people like start a bit about real analysis. Sometimes you guys feel like this is what the hell this is. So can you just type an answer? What is real analysis means? Why would this name come? Or like as you feel, can you someone answer? Or for the newcomers, actually the feel is actually I agree with the answer. The real analysis is in this section in mathematics we analyze about the real numbers. Okay, so it means in our A levels or in our A level times, so we studied about the real numbers, the functions, and so on, without saying it is real numbers, right? We know what real numbers like තාත්වික සංඛ්‍යා කියන්නේ අපි. We know, but the thing is, in real numbers, we don't much care about the very basic fundamental. For an example, we don't care how summation of two, let's say 2 plus 3, we know we take it is equal to 5. But we don't argue the fact that how the hell the summation of two real numbers is itself a real number. So it is like actually we call some axioms and so on. So it means in real analysis, what we do is most time actually you can in the addition or subtraction or multiplication or division, there are some sort of like axioms and so on. So there are some sort of like basic thing that we need to understand in order to like define these operator properly. Actually in university mathematics you don't need to that much detail how the like how these things come or how these basic rules are defined. There are like 10 axioms, but those 10 axioms are not so important in university mathematics since you are engineering undergraduates. But the thing is, when you come into the real analysis, you need to, let's say, some sort of like something more. Let's say it is limit x equal to 1 equal x plus 1 equals 2. In our case, in A level days, what we do, we just take this one and we substitute to this one. So it gives the answer. We say it is the limit. But in university or in like higher level, actually in mathematics, this thing cannot be say like this. To define these quantity with something called definitions. in mathematics, everything we have like couple of things. One thing is like some sort of definition. It means definitions means you introduce something. ඒ කියන්නේ හඳුන්වා දීමක් වගේ. ඒ කියන්නේ limit එකක් කියන්නේ මොකක්ද? It is called definition. And also you can have theorems or lemmas. So the basic difference between definitions and theorems or lemmas, it means definitions can't be proved. But theorems or lemmas can be proved. So that's you need to understand, because in universal method, like when you understand real analysis, you often encounter the name definitions and theorems or lemmas or propositions, or you can also put propositions here. It means definitions mean the thing of very basic level. When you heard the word definition, you need to remember it is the very basic thing. It means you cannot derive that thing from another thing. But in theorems or lemmas, what will happen is we will use these basic fundamentals to derive more complex, like complex relations that can be proven. For an example, you know limits fx equals L and limits x goes to a gx, let's say it is M. We know limit x goes to a fx into gx, it is equal to Lm. This is instead a theorem. So these kind of things can be proven. So these are the basic terminologies actually I want to explain to you, because otherwise you may wonder, because in A levels we don't like අපි සිද්ධාන්තය අර්ථ දැක්වීම එහෙම ලොකුවට අපි වචනවලට අවධානයක් දුන්නේ නැහැ. ඒ කියන්නේ ඇත්තට මේ ඩිෆිනිෂන් එක කියන්නේ අර්ථ දැක්වීම. තියරම් එක කියන්නේ සිද්ධාන්තය. ඇත්තටම ලෙමා එකක් නම් කියන්නේ මොකද්ද කියලා මම දන්නේ නැහැ. ලෙමා එකට කියන සිංහලෙන් කියන්නේ මොකක්ද කියන එක ඇත්තටම මම දන්නේ නැහැ. ලෙමා එකක් කියන්නේ මොකක්ද කියලා. ප්‍රොපොසිෂන් එකෙත් ඇත්තටම සිංහල වචනේ මම හරියටම දන්නේ නැහැ මොකක්ද ඒකට කියන්නේ සිංහලෙන් වචනේ කියලා. සාමාන්‍යයෙන් ওই තුනම නිකන් එක වගේ යන තුනක්. එතකොට දැන් ඕක තමයි අපේ දැන් ඔය ටික අපේ ඔහම තියෙනකොට අපේ දැන් මුලින්ම දැන් ඒතර අපි දැන් ඇත්තටම රියැලිසිස් කියන සබ්ජෙක්ට් එක ඇතුලේ අපි කරන්නේ මේ නැත්නම් තාත්වික රියැලිසිස් කියන තාත්වික විශ්ලේෂණ. මේ රියල් ඇනලිසිස් කියන මේ තාත්වික කොටි මම මේ ඉගෙන කතා කරන්නේ තාත්වික සංඛ්‍යා එහෙම නැත්නම් රියල් නම්බර්ස් ගැන. අපි මේක ඇතුලේ කරන්නේ මේ රියල් නම්බර්ස් වල තියෙන ගුණයන් එකින් එක විශ්ලේෂණය කරන් යන එක. එතකොට මෙතනදී ඔයගොල්ලන්ට සමහරක් දේවල් හිතෙන්න පුළුවන් ඇයි අපි මේ දේ කරන්නේ, මේ දේ ඇත්තටම ගණිතයේ තියෙනවා, මේක අපි කරන්න ඕන දෙයක් නෙමෙයි. මොකද සමහර ඔප්පු කිරීම දක්වාට හිතෙන්න පුළුවන් මේක ඔප්පු කරන්න ඕනේ නැහැනේ, ඇයි අපි මේ ඔප්පු කරන්නේ. හැබැයි අපිට ඒක කරන්න වෙලා තියෙනවා මොකද ඒක බේසික් ඩෙෆිනිෂන් එකක් නොවන නිසා. ඔයගොල්ලන්ට ලොකු ප්‍රශ්නයක් තමයි ඇනලිසිස් ඉගෙන ගන්නකොට තියෙන, ඇයි අපි මේ දේවල් ඔප්පු කරන්නේ, ඇයි මේක මේ තියරම් එකක් විදිහට කියන්නේ. හේතුව තමයි අපි මෙච්චර කාලයක් මැත්ස් කියන දේ ඉගෙන ගත්තේ අර ඉස්කෝලේ යන කාලේ ඔක්කොම නිකන් අකන අපි කරේ උඩින් අතපත ගෑව වගේ දෙයක් තමයි මෙච්චර කාලයක් නම් කරලා තියෙන්නේ. ඔය රියල් ඇනලිසිස් එකේදී කරන්නේ ඒකේ පරතරයට ගිහිල්ලා කියනවා මේක තමයි ගණිතයේ තියෙන මූලික නීති ටික, මේ දේවල් වලින් තමයි ගණිතය ගොඩනගෙන්නේ කියන එක. අර ඒකයි පොඩ්ඩක් නිකන් අnder tamil වගේ තියෙන්නේ. In this real analysis, what we do is actually we explore the very basic fundamentals of mathematics. Using its very basic rules and definitions, we trying to derive the things we encounter in real life. In A levels or O levels, we don't care that much. That's why you feel real analysis is like some sort of like foreign language or something difficult to understand. Sometimes you even see why we need to prove this one. Okay. For an example, we analyze real number. We start with real number line as a starting point. Okay. So let's take some arbitrary two real numbers to get some starting point. So now I'm going to prove that if I ask you the question, I'm like see you the difference between real analysis and or the way we learn mathematics before the A levels. So if I ask, are there any real number in between these x and y, what is your answer? If I ask someone, I have the real number line and I have two different real numbers x and y, and now I'm asking the question, are there any real number between x and y? What will be your answer? Yes. We know in A levels we straight away say we have infinite number of real numbers. But in real analysis, you cannot straight away say that because it is not the basic fundamental thing we define in mathematics, right? So here, how we can do this thing, because it is actually this thing can be actually this is the pretty much basic thing that you learn. I think pretty much out of the very first thing you should learn in real analysis. These proofs can be asked in exams as well. Let's assume you need to prove a real number in between these things. First, I'm going to show you. Okay, before going to prove that one, I introduce some another number. Let's call, we denote this as q and we hit a bar. We call these numbers as rational numbers. Right? Rational numbers is, that is sometimes we denote it as, let's say r is, let's say, rational numbers. I think the notation is correct. Sometimes I mess with the notation. Let me double check the notation. Yeah, it is q, right? Typically we note it as q. So then it is something like this. Rational number is something like p over q, and this p and q are both integers. And it means rational numbers can අපි ඇත්තටම සිංහලෙන් කිව්වොත් අපි සිංහල වලට කියනවා ඒතර සිංහල කියන නම්බර තමයි. අපි මේකට කියන සාමාන්‍යයෙන් පරිමේය සංඛ්‍යා. rational numbers කියන පරිමේය සංඛ්‍යා. ඒ කියන්නේ සාමාන්‍යයෙන් අපි rational number එක කියන අපිට භාගයක් විදියට ලියන්න පුළුවන් සංඛ්‍යාවකට අපි කියනවා rational number එකක් කියලා. එතකොට මේ තියෙන rational number අපි reduce form කියලා කියනවා. සාමාන්‍ය මේ වචන ඔයගලන්ට හම්බ වෙනවා. මේ p, q ට common factor එකක් නැත්තම්. ඒ කියන්නේ උදාහරණයක් විදිහට අපි ගත්තොත් 4න් 2 කියන එක්කෙනා reduce form එකෙන් නැහැ. හැබැයි 3න් 2 කියන එක්කෙනා reduce form එකෙන් ඉන්නවා. The reduce form is if you write your rational number as p over q, then p and q are integers and they can't have a common factor. If you take the factor 2 over 4, it has a common term 2 to both numerator and the denominator. But if you take the factor 2 over 3, it has no common factor to numerator and the denominator. Actually, I think I explained in the previous explanations as well. Numerator is your, like the number on the top, and denominator is the number at the bottom. Right? හරේ සහ ලවය කියන්නේ අපි හරේ කියන්නේ numerator, ලවය කියන්නේ denominator. එතකොට so then first I am going, because we know if you take any real number, there can be two things to happen. If one thing is it can be a rational number, other thing is it can be a irrational number. It means you have typically, it means if you take any real number, let's say x is a real number, it can two things happen. One thing, x can be a rational number or x can be a irrational number. ඒ කියන්නේ අපි ඕනම තාත්වික සංඛ්‍යාවක් ගත්තොත් එක්ක පරිමේයයි නැත්නම් අපරිමේයයි. කතාව ඔච්චරනේ. So to prove this one, right? So to prove this one, I am going to do something like this. I am going to show first there is a rational number in between x comma y. So because we know there are two types of real numbers. One thing is rational numbers and the other thing is irrational numbers. So since the rational numbers are like pretty much ordered to pretty much sometimes you go because it's a fractions and you can easily represent them, I'm thinking of the way to show there is a rational number in between x and y. Because this is a pretty much basic problem, I'm explaining to you in this in detail because this is the way when you should think about are there any problem? Oh, I think someone says unmuted the mic. If there's a problem, you can ask. කෙනෙක් අහලා තියෙනවා if p over q reduced form එකේ තියෙනක අනිවාර්යද? In rational numbers Yes, because in technically because you can have rational numbers which are not in the reduced form, but if you need to like take a set of rational numbers, then they need to have in the reduced form. Otherwise, the same number gets duplicated. So when you define the rational number, any number can be written as a factor. It is a rational number. But if you need to uniquely identify the rational number, then you need to have it in the reduced form. කියන්නේ සිංහලෙන් කියනවා නම් ඔයාලට rational number එක reduced form එකේ නැතුව තියෙන්න පුළුවන්. හැබැයි ඔයාලට uniquely rational number එක represent කරන්න ඕන නම් ඔයාව identify කරන්න ඕන නම් එයාව reduced form එකෙන් තියෙන්න ඕනේ. මොකද එතකොට තමයි rational numbers එක වෙන වෙනම අඳුරගන්න. උදාහරණයක් දෙන්න ගත්තොත් half කියන එකයි 2 half කියන එක rational numbers දෙකක් නෙමෙයි එකක්. ඒතර ඒ වගේ තැනකදී රිඩියස් ෆෝම් එකකින් තියන්න කියලා අපි ගොඩක් වෙලාට තියන්න පෙළෙන්නේ. එතකොට අපිට රැෂනල් නම්බර් එක එක විදිහකට විතරයි තියෙන්න පුළුවන්. අර එකම නම්බරේ විදි කොටකින් තිබ්බම අපිට අඳුර ගන්න අමාරු නිසා අපි ගොඩක් වෙලාට ප්‍රැක්ටිස් එකක් විදිහට රිඩියස් ෆෝම් එකෙන් තියෙනවා. Right. So in this way, so now how I'm going to do that. So in this real number, I know there should be some real number in between, but I need to prove this one. So then, if I need to prove a real number in between x and y, I know a real number can be either irrational or rational. So first, I am going to show there is a rational number in between x and y. So then I can at least say, if you take any two real numbers, there is a rational number between those two real numbers. So now, how are we going to think this in mathematical? So this is the way you should be thinking, right? Because if you think in this way and you develop this logical thinking, there's this module is going to be very easy. Real analysis is going to be very easy. Otherwise, it is going to be memorizing things. You say this type of problem can be solved in this way, this type of problem is solved in this way, and you don't get anything, and you like feeling like reading some French stuff or something, and reading an article in a language that you don't know. ඒ කියන්නේ නිකන් අnder tamil වගේ කියන්නේ අපි නිකන් අර කෙලින්ම නිකන් ග්‍රීක් ආටිකල් එකක් කියනවා වගේ. එහෙම වෙලා වැඩක් නැහැ. ඒ කියන්නේ අපි රියල් ඇනලිසිස් වලදී කරන්න ඕනේ මේ හැම පියවරක් අස්සෙම ඒක කරන විදියක් තියෙනවා. දැන් මෙතන මම කරන්නේ xy අතර රෙෂනල් නම්බර් එකක් ඉන්නවා කියලා පෙන්වන්න. දැන් ඔක හිතන විදිය බලන්න. මම නිකමට මෙහෙම හිතනවා. මමගේ තාත්වික සංඛ්‍යා රේඛාව ගත්තොත් මම ගන්නවා 1 2 3 4 5 මම ඔහම numbers ටික දාගෙන යනවා. I take the real number and I just take some natural numbers, right? These are called actually natural numbers. We denote as n. It means 1, 2, 3, 4. අපි ගන්න සංඛ්‍යා කියන්නේ the numbers we are used to count things, because we don't take minus numbers to count, right? We don't say minus 1x or minus 5x. We say 1x, 2x, 3x, that kind of thing. Natural numbers are the numbers that we can take to count the things. So if you take these things, because these are the pretty much normal numbers we know actually in our days, actually like alphabet of mathematics, like these are the pretty much simplest numbers that you can take. Now, what you can say, because in this very basic form of the real number line, it means if you take any 2 points of this in real number, like any 2 points in this real number line, right? If this length is greater than 1, if this length is greater than 1, you will find a natural number or an integer on this line, right? ඒ කියන්නේ අපි ඒකක එකට වඩා දුරකින් තියෙන පොයින්ට්ස් එකක් ගත්තොත් ඒ දෙන්න මැද්දේ අනිවාර්යයෙන්ම නිකිලයක් ඉන්න ඕන කියන කෝල පිළිගන්නවනේ. කියන්නේ 1 2 3 4 රිලේ 1 2 වගේ තියෙන ඉලක්ක තමයි. ඒ කියන්නේ ඔයාට රියල් නම්බර් එකේ ලයින් එකේ ඒකක එකට වඩා දිගින් වැඩි ලයින් එක ඒ කියන්නේ ඒක දෙකට වඩා දුරකින් තියෙන විදිහට පොයින්ට් දෙකක් ලකුණු කරන්න පුළුවන්ද ඒ දෙන්න මැද්දේ ඉන්ටිජර් එකක්. එහෙම නැත්නම් නිකිලයක් නැති විදිහට. Anyone? Hello? අපිට එහෙම කරන්න බෑ. ඒ කියන්නේ අපි දන්නවා අපි ඕනම numbers එකක් ගත්තොත් if we take any two numbers, the gap between those two numbers is greater than 1, we will always find an integer in between those two numbers. So let's assume, because in this case actually we take y is greater than x, so then let's assume this number, let's say y minus x. Okay. Now we don't know whether this number can be number can be now, because we need to prove in between x and y, right? So this number can be greater than or equal to 1 or less than 1. If this happens, we are already done, because we can say there is an integer between x and y. But here we cannot say it indirectly, because y is less than 1. Let's say, so it can be like something like this, right? So then in this way, there's no an integer. So then what we're going to do is, we get some number like this. We take very large number, let's say very large integer, m. M is nothing but a very large integer. So then we assume minus x value greater than 1. Let's say because if you take the integers or integer numbers or natural numbers, you can assume very large number, right? Because you cannot say what is the largest integer is. So then you can always choose some larger integers where if you multiply your difference, it will result a number greater than 1. It means now if you put mx and my, this difference going to be greater than 1. It means there will be definitely some integer, let's say a, or let's say we denote it as little m, simple m, between those two numbers. It means we can say we can choose a large m equal to integer, such that y minus x times m greater than 1. මෙයාගෙන් මට කෙලින්ම කියන්න පුළුවන්. So there is an integer m between mx and my. It means you have an integer m such a way that in between these two numbers, right? You don't have to put the equal sign there. It means you have this number between x and y. This is nothing but a rational, because this is an integer, this is an integer, right? Actually this is a in if you see in A-level A-level knowledge, or when you just come to the university, you may feel that this is nothing to prove. But in the real analysis is, those are the things we need to prove. So we need to prove into pretty much it means the basic law, because I just do it as a problem to show you something, because that it can be proven. And the first thing you need to do to learn analysis is forget about the things you take in for granted. It means ඉගෙන ඔක රියල් ඇනලිසිස් ඉගෙන ගන්නවා නම් කරන්න ඕන පළවෙනි දේ තමයි අපි අර ගණිතයේදී නිකන් ඔහේ දාපු දේවල් ටික අර එහෙම දාන්න පුළුවන් කියලා අපි ඔලුවට දාගෙන ඉන්නක චුට්ටකට අයින් කරන්න වෙනවා. ඒක නේ දේවල් අමතක කරන්න කියන එක නෙමෙයි, පොඩ්ඩකට අයින් කරන්න. මොකද ඒ වගේ දේවල් ඔප්පු කිරීමක් එනකොට ඕගොල්ලෝ හැමතිස්සෙම ඒක දැකපු ගමන් මේක අපිට කියන්න දෙයක් නෙමෙයිනේ කියන කොළුවේ දාන්න හිටියොත් ඕගොල්ලන්ට මේක ඉගෙන ගන්න එක පොඩ්ඩක් අමාරු වෙනවා. මේක තේරෙනවද කරපු දේ? ගමේ පොඩි සරල ලොජික් එකක් කිව්වේ. hello ඒක ඕකේද?
Yeah.
හරි. දැන් ඔය එක දෙයක්. දැන් මට කියන්න දැන් මෙහෙම දෙයක්. දැන් අපි කිව්වේ දැන් ඕනම සාතික සංඛ්‍යාවක් දෙකක් මැද රෂනල් එකක් තියෙනවා කියලානේ. දැන් මට ඕනේ කියන්න මොකක් ගන්නවා xy කියලා එක්කනේ. දැන් අපි දන්නවා xy කියලා ඕනම තාත්වික සංඛ්‍යා දෙකක් ගත්තට පස්සේ මම y කෙනෙක් නැවත ඉස්සර පොඩ ලොකුවට ලියනවා. මේ දෙන්න මැද්දේ රෂනල් එක්කෙනෙක් ඉන්නවා. දැන් මට ඕනේ මේ දෙන්න මැද්දේ ඉරෂනල් එක්කෙනෙක් ඉන්නවා කියලා. කොහොමද මම මේක කියන්නේ? දැන් මේ රියල් ඇනලිසිස් වල හිතන විදිය කියන්නේ. Right? First we prove that if you take any two real numbers, right? If you take any two real numbers, okay, I'll come back to that point. Okay, so if you take any two real numbers, how you going to prove there is an irrational number in between x and y. Is this. We know if you take any two real numbers. So what about this real number? What about these two numbers? This also a real number, because we know the multiplication of any two real numbers is a real number, and this is also a real number. It means we should have some rational number, let's say a or b or something, between these two real numbers. It means we should have a over root 2p y in between these two real numbers. So since this is a rational, okay, this is a rational number. We all know root 2 is an irrational number. This total become an irrational number. It means if you take any two real numbers, you can have an irrational number in between those two real numbers. Now, actually someone asked in the chat, if you take x and y, can't we say x plus y divided by 2 in between these two numbers? That is correct. But if someone asks, if you have a rational number in between those x and y values, you cannot say that. If someone asks, prove that there is a irrational number in between any two real numbers, you cannot do that one. But if someone simply asks, prove that there's a real number in between any two real numbers, you can do it that way. But if when someone asks, prove that there is an irrational number and a rational number in between any two of real numbers, you can't do in that way, because you don't know what will the resulting x and y would be. For an example, let's say x equals 1, y equals 3, you would get x plus y over 2 equals 2. But in some instance, you can have x equals 1 and y equals root 2. So then you can have x plus y equals 2 as 1 plus root 2 over 2. This is a rational number. So then you cannot say, you don't know what is the value, what is the value of this r, but you know it is a real number. That's the only information you have. But if you need to prove there is definitely a rational number in between those two numbers, or definitely irrational number in between those two images, that is the thing that you need to do. Let me check. Okay. So then, okay. Now we have studied some sort of like, I think you need to get idea what is about this real number. So then this is the kind of thing that you need to know. So then when we defining these things in mathematical languages, we have some sort of like syntax or some sort of mathematical language, because I think this that basic thing that I need to do, because it means in real numbers that you need to, because this is to do, because I did this to show you, you need to have some sort of thinking pattern or thinking to depth into the details of pretty much basic fundamentals to go with the real analysis. If you think in that way, because I just using this term because you need to have some sort of visualization. It means if you some problem is given to you, you need kind of thing what we do in like in grade 5 or 6, that we visualize always. Let's say how this thing happened. So how these numbers placed on the real number line. Those kind of things can be come into the play in the real analysis. Okay. Before going into the much detail on these things. Okay. So thing is this one. So rational number එකෙන් බෙදුවාම කෙනෙක් අහලා තියෙනවා irrational කියලා කියන්නේ කොහොමද? In mathematics, there's a theorem. Let's say you can say simply one real. You can say it is let's say you can say some number as let's say 3. This we know, and 3 over, let's say 3 over 2, and then you take the 2 over 3 root 2 divided by root 2. So then you have root 2 over 3. We know because this irrational number, you cannot express this as a fraction. Right? You cannot express the root 2 as a fraction. Then you cannot express this whole thing as a fraction. That's the intuitive idea. But itself, yes, it is not a straightforward thing. You can always prove this thing using definition, but I'm not going to that detail, right? So then you have to some sort of limit. So then that's why I'm like like telling this to you, you need to understand, you like in the lectures when you having, they are properly said what are the definitions or what are the results that can be used in directly. They will specify almost in the lectures. They will specify what are in the every time you will in field analysis in every course. It specify what are the things that you can use without a proof. There are something that you cannot use without a proof. So in most cases, these kind of thing that you can use without a proof. But if you learn very advanced mathematics, sometimes even this you cannot use without a proof. It depends on the context, right? So okay. Now I think just I want to highlight about the thinking pattern of what is the like real analysis subject looks like. Then we'll try to learn some sort of like syntaxes or what to call like in mathematical and I just say mathematical language. Okay. Now I think 21 people might see this notation. Can someone say what is this notation? Like a V and a bar across its arms. What is this notation means? Can anyone say? Yeah, for all. And also there is something other thing called is there exists. Okay. For all means also there is something called there exists unique. Actually, I put a YouTube video as well. So you can say something like this. Let's say I just write some toy example. Let's say for all x, we can say 2x is for let's say for all x in integers, we can say 2x is even. It means in this term for all x means if you specify x in this area for all x, it means any value that satisfies this criterion, we can say 2 times that one is even. සිංහලෙන් කියනවා නම් x කියන්නේ නිකල සංඛ්‍යාවක් නම් එයාව දෙකෙන් වැඩි කරාම එයා ඉරට්ටේ සංඛ්‍යාවක් කියන එක මේ කියලා තියෙනවා. even කියන්නේ ඉරට්ටේ. හරි? දැන් මෙහෙම කිව්වොත් there exists x in real numbers such a way that x is even. මේක මොකක්ද කියන්නේ? x කියලා තාත්වික සංඛ්‍යා තියෙනවා ඒවා ඉරට්ටේ වෙනවා. මේකෙන් කියවෙන්නේ නැහැ හැම තාත්වික සංඛ්‍යාවක්ම ඉරට්ටේ කියලා. ඒ කියන්නේ යම්කිසි එදයා එක්සිස් කියන එක කියන්නේ ඔයාට තාත්වික සංඛ්‍යා කුලකේ ගත්තොත් x තාත්වික සංඛ්‍යාවක් වෙන විදියට x ඉරට්ටේ සංඛ්‍යාවක් හොයලා දෙන්න පුළුවන් කියන එක තමයි මේකේ අයිඩියා එක. ඒ කියන්නේ කොටිම කියන්නේ මේකෙන් කියන්නේ හැමෝටම. මේකෙන් කියන්නේ ඒ කියන්නේ එකක් හරි තියෙනවා. හරි? ඒ කියන්නේ තාත්වික සංඛ්‍යා එකක් කියන්නේ මෙන්න මේක හරියන්න මේ දෙයක් එක්සිස් කියලා ලියපු ගමන් ඒ ලියලා තියෙන දෙයක් හරියන්න නම් එයා හරියන විදිහේ එකක් හිටියත් ඇති. හැබැයි එකක් ඉන්නත් පුළුවන් දෙකක් ඉන්නත් පුළුවන් තුනක් ඉන්නත් පුළුවන්. හැබැයි තව එක්කෙනෙක් ඉන්නවා there exists unique කියලා. මේකෙන් කියන්නේ මේ කියන්නේ මේ වගේ ලියලා තියෙන දැන් there exists unique x in real numbers such that මට ගන්න පුළුවන් a plus x equals a for all a in real numbers. මේක මේ කියලා තියෙන්නේ මට x කියලා එක්කෙනයි තාත්වික සංඛ්‍යා පද්ධතිය ඉන්නේ ඕනම a කියලා තාත්වික සංඛ්‍යාවකට x කියන එක්කෙනාව එකතු කරාම මට ඒවම හම්බෙන්නේ. මේක ඇත්තට මේ නොකේ කියලා තියෙන්නේ බිඳුව ගැන. මොකද බිඳුව විතරනේ හැම එක්කෙනෙක් ඉන්නේ. මගේ තාත්වික සංඛ්‍යා පද්ධතිය ගත්තොත් ඕනම තාත්වික සංඛ්‍යාවකට මේ බිඳුව එකතු කරොත් මට ලැබෙන්නේ මේ තාත්වික සංඛ්‍යාව. ඒ හැසිරීම පෙන්වන්න වෙන කිසිම තාත්වික සංඛ්‍යාවකට බෑ. මෙන්න මේ වගේ ඒවට අපි කියනවා quantifiers කියලා. මේ quantifiers අපි ඇත්තටම පාවිච්චි කරන්නේ අර mathematics වලින් theories definitions එහෙම ලියනකොට ඒ ලියන්න තියෙන ඉඩ අඩු කරගන්න. මොකද හිතන්නකෝ මොකක් හරි ඔය ඩෙෆිනිෂන් එක ලියන්න ගියාම for all x there x කියලා වචනෙන් ලියන්න ගියොත් මොකද වෙන්නේ? මේක ලියන්න ලොකු ඉඩක් එනවා. ඒ ඉඩ අඩු කරගෙන පුළුවන් තරම් සරලව තමන්ගේ ඩෙෆිනිෂන්ස් එක ලියාගන්න තමයි අපි මේ quantifiers කියන දේ පාවිච්චි කරන්නේ. ඊට අමතරව තව දේවල් සෙට් එකක් තියෙන මෙන්න මෙහෙම එකක්. මේව දෙන්නකො. A implies B. මෙන්න මේක දැකලා තියෙනවා. මෙන්න මේකට අපි කියනවා implies. මම ඩෙෆිනිෂන්ස් වලට එන්න ඉස්සර වෙලා තියෙන පොඩි සරල දේවල් ටිකක් කියාගෙන යන්න. මේ implies කියන්නේ මොකද්ද? කාටද කියන්න පුළුවන්ද? ඕගලන්ට මට කියන්න මේ do you guys cover logics in first semester? 21 people? Do anything called logics and set theory or something? If it is, you probably cover the like in-depth knowledge of this notation. But otherwise, I will give you some brief idea because without knowing this thing, okay, you don't have again. You don't have to call me sir. Okay. So A implies B. What does this thing mean? Actually, today I'm not going to think it's my not specific theory. I'm just trying to give you some introduction to the real analysis. So in a way that you can learn the things clearly. Otherwise, you will feel like some sort of foreign language and you will feel difficult. Because I know real science is difficult. No, it is only if. Yeah. Something like this. A implies B means B is, let's say, if A is true, B is true. This simply means if you know A is true, then definitely B is true. But it doesn't mean that if B is true, it doesn't guarantee anything. It means you can have, let's say, A true, then your B should always true. But A false, you can have B either true or false. Okay. So this only guarantees if A is true, B is also true. There's also some other thing. A, this guy. What does this guy mean? Now we have two arrows. This is actually we say equivalence, or this simply, I just put in this here. This simply equivalent saying A implies B and B implies A. It means if A is true, then definitely B is true. If B is true, then definitely A is true. Okay? there exists sign එකට පස්සේ තියෙන sign එකෙන්ම කියන්නේ එකම තේරුමක් නේද? නැහැ වැරදි. there exist කියන්නේ ඒක හරියන්න නම් ඒ කියන විදියට එකක් හෝ කීපයක් තිබ්බනම් හරි. හැබැයි there exists unique කිව්වොත් හිතන්නකෝ මෙහෙම. there exist unique කියලා මොකක් හරි එකක් කියලා තියෙනවනම් මෙයා හරියන විදියට අගයන් දෙකක් හිටියොත් මෙයා වරදිනවා. මොකද there exists unique කියන්නේ එයාව හරියන විදියට ඉන්න පුළුවන් එක්කෙනයි. there exist කිව්වොත් එක්කෙනෙක් ඉන්නත් පුළුවන්. කියන්නේ මේ මෙන්න මෙයා හිටියේ නැත්තම් මෙන්න මේ පාර්ට් එක තිබ්බේ නැත්තම් එක්කෙනෙක් ඉන්නත් පුළුවන්, දෙන්නෙක් ඉන්නත් පුළුවන්, තුන් දෙනෙක් ඉන්නත් පුළුවන්, කැමති ගාණක් ඉන්න පුළුවන්. ඔක්කොටම හරියන්නත් පුළුවන්. හැබැයි there is this unique කියපු ගමන් අපි ඒක පාලනය කරනවා. ඔයාට ඒ කියන දේ හරියන විදිහෙන් එක්කෙනා ඉන්න පුළුවන්, එක්කෙනෙක්ට වඩා ඉන්න බෑ. එක්කෙනෙක්ට වඩා හිටියොත් කියන දේ වරදිනවා. පැහැදිලි? සමහර මේක ගොඩාක්ම හම්බෙන්නේ නැහැ මැතමැටික්ස් පැතිවල. සමහර තැන්වල ලිමිට්ස් වල සමහර තැන් ලිමිට් ඉස් යුනික් කියන තැන්වල ඩෙෆිනිෂන් වල ගොඩක් වෙලා සමහරක් වෙලාවට මේක හම්බෙන්න පුළුවන්. ඒක මම ඔයගොල්ලන්ට කියලා ගියේ. පැහැදිලි? hello පැහැදිලිද? hello පැහැදිලිද? Now you know a bit about like syntaxes and these implications and so on. Okay. Now see how these things actually get in practice. To do that, I will give you some introduction on intervals. Right? Not I don't give you any interval. Like just explain about intervals. Otherwise, actually I will do some brief introduction. Actually, not something like this. Let's say if you take real numbers, you take some sort of area or some sort of length in this real number. And this thing basically you call an interval. Let's say the starting point is A, ending point is B. So there are a couple of, you can denote these intervals. Let's say you denote specifically as I. You can have couple of variation of this interval. One is A, B. Another thing is A, B, and A, B, and you can have A, B. So these are the four things that you can have. So there are two main brackets that you can use. One is this curvy thing, another thing is this square bracket thing. Okay, so if you have this kind of thing, actually we call usually this thing is open bracket. This we can actually close bracket. It means if we use this circle shaped bracket, it means this A is not belong to this interval here as well. If you use this square bracket, it means A is belong to this interval. Okay. So then actually we actually is called this open and open interval because both brackets are open. Here we close because both are square brackets, closed, closed. But here open, closed interval. Here actually closed, open interval. Okay. So the bracket in because there are two things, because you can have interval something like this. Let's say x, you can have x greater than or equal to a less than or equal to b. This is actually can be denoted as a b. Let's say x in this, right? Also you can have x greater than a less than b. This is denoted as x in open bracket and open bracket. Did you guys see the difference between these intervals? Hello, did you see the how this, right? Or do you guys have any problem with that? Because these are the very basic things that you need to know, because in definitions you will not know this, you will find these things, otherwise it is going to be a problem. So it is the way to remember is, if you say square brackets, the number should belong to that interval, or if you use like circle shaped bracket or normal bracket, like your open bracket, your number does not belong to your set. Okay, hello. Okay, now these are the intervals that I tried to tell you. Now if we take any set, let's say I assume say some sort of real number set, these are set of real numbers. We defined upper bounds. Upper bound means, let's say upper bound means, let's say something like this. We say u is an upper bound implies u greater than or equal to a, or we can say for all a implies to a, u greater than or equal to a. So this is the way you can write. I will explain into that. It means u is an upper bound. Upper bound is if you take some set of real numbers, if you can choose some real number greater than or equal to all of these elements, you call it an upper bound. If you denote it as a graphically, if you take your real number like, if you place all of your real numbers, let's say something like this, then let's say this is the largest real number. So you put somewhere here some real number. So it is greater than your all of your set, because these the numbers you consider. You can treat this as an upper bound. Upper bound means a number that is larger than every element of your set. Understood? Hello? Understood? Hello? Anyone? Okay. Now when lower bound, let's say I just write in the quantifiers form just to get understanding, right? If you need a single explanation, please let me know, right? A lower bound, it is implies For all A into A, your L is less than or equal to A. It means the lower bound is, let's say your numbers are here. These are your numbers. So your lower bound should be somewhere here. Right? These are lower bound. It means if you take all the numbers in your set, and then you can find some real number which is smaller than all of these numbers, you call it a lower bound. Fine? Yeah. So larger than or equal. So your upper bound can be equal, right? Because that's how you define an upper bound, right? If you can find some number that is larger than or equal to every element of your set, you can call it an upper bound. It means you cannot find an element inside your set that is larger than your upper bound. And also in the lower bound case, your lower number, if you take any number from your set, your number should be greater than or equal to your lower bound. In other words, you cannot find an element in your set which is smaller than your lower bound. Fine? Hello? Hello? Okay. And in mathematics, we say if we have a lower bound and upper bound, we call it the set is bounded. If you have upper bound and lower bound, you can say set is bounded. If someone say your set is bounded, it means it has both upper bound and a lower bound. Okay. Now we know what is an upper bound is. It was pretty simple, right? You feel very simple. Now I'm going to show you the real picture or the real complex thing, right? I'm now going to make your life a bit hard. So I know it is already hard to listen my voice for I think nearly an hour. That's okay. Sorry for you because I know my voice is pretty much bad. Anyway, that's why I'm not singing, right? So I don't let people suffer from my voice. Anyway, I have to teach. I cannot change my voice, so you have to listen it anyway. Okay. So now there's two concepts called supremum. Now we are going into bit into depth. Supremum and infimum. Supremum is smallest upper bound. And infimum is largest lower bound. Okay. Now, my question is this definition is enough for mathematics? Because if you take a set, you can choose any number which is larger than or equivalent to all the numbers in the set as an upper bound. And then you simply say your smallest upper bound is your supremum. But this is basically the thing that you say. But I am asking whether this is enough for mathematicians or enough to convey the idea correctly. What is the difference between set and interval? Okay, interval is like this, right? It is only a one shot, right? I'll just give an answer to that also. Let's say if you take real number line, if you take some stripe like this is an interval. But if you take something like this and you take all the numbers together, it is a set. It is actually basically a collection of one or more intervals. Interval is basically a set, but in a set that can be have discrete part of your real number line. Okay, I think you got the idea. Hello. Because in a set, let's say if you say some set, let's say it's very simple set 2, 3, 5. So then you have some 3 distinct point on the real number line. Okay, I think you get the idea. Hello. Fine. Okay. I think get the idea. It is basically you can think of it as the interval is some continuous stripe of the real number line, and the set means a collection of one or two these intervals. It can be discrete as well. Again, don't call me sir, right? So you can call me Ayya or any other thing that you want to call by my name. I don't mind that one, but when you say say sir, it means I feel pretty much old, right? So it means my younger days are gone. So then I am upset. So don't call me like that. And anyway, you don't have to call like that one, right? So in other countries, even the professors don't expect to call that one. So like just call by name, right? So that's the name for the whole purpose. The name is to identify the person. So why the hell you call sir, right? So just tell my name. That's enough. Okay. So then now we are gonna mathematically say this thing, right? Now please pay attention, right? Okay. We denote supremum as, first of all, I just drag a bit. We denote this as sup of, let's say, A. I take my set as A, right? So then I denote this as this. For all epsilon greater than 0, there exists A naught in A such that A naught plus epsilon greater than supremum of A. This double implies supremum of A, or let's say we take it is S for now. S is the supremum of A. Okay. This means something like this. If you take any real number, let's say let's note this as a Venn diagram. If you take any real number, this real number can be 1,000, 100, or uh, 0.0, 0.00, 100 zeros and one, and any small positive number. The only uh, condition to satisfy it is it is been a positive number. So you can choose any arbitrary small epsilon, and for every epsilon you can choose an element of this my set. Every epsilon you can choose some element, a naught element inside this set, such a way that if you add epsilon to this element, it is larger than your supreme. So this is the way you tell this exact same thing in a mathematical way. In these two definitions, there's no difference between this and this. But here is only 3 words. But here, 2 quantifiers and 1 double implication. And it is actually pretty much like mathematical and like what you call very much notational thing. But the thing is, you need to understand this. It means it is simply saying you have, for every positive number that you can imagine, no matter how it is small, you can always pick some element inside your set A naught. When you add epsilon to that element, it is larger than your supremum value. What does this mean? Let's graphically draw this. If you take your real number, and this is your supremum, right? It means you take epsilon, right? Let's say this is not hold for, let's say when epsilon equal 0.1, you cannot find A naught. Okay, you cannot find A naught such a way that A naught plus epsilon, let's say A naught plus let's say you cannot find something like A naught plus 0.1 greater than or superior. You cannot find this one. This doesn't hold. It means if you go 0.1 distant to the left from your S, or to the minus side of the real number line, you cannot have any element in this area. It means you can simply put S plus 0.1 over 2, or this middle point, or any number between those two in this between those S minus 0.1 and S real numbers. You can use it as a upper bound, because if you take any number, let's say u, any number u, right? If you take any number u between S and S minus 0.1, it will be an upper bound for the set u, because you cannot have an element greater than this value. If this doesn't happen, then what will happen? This upper bound is less than your supremum. You cannot have that one, right? Then you can find the upper bound less than your supremum. Okay, that is what this means, right? This simply means you cannot find an upper bound below S. That is the simple meaning this complex expression conveys. So when you learn in real analysis, don't memorize this type of thing. This you can memorize. As memorize means if you know the quantifiers, you can write this. The most importantly, try to describe what the hell these type of definitions say. That is where half of the people fail and half of the people find it difficult, and then you are nowhere going, right? If you can learn in this way, the real analysis is very easy. It is actually you can straight away get an A plus. I'll guarantee you. But if you try to learn this and memorize, they say the supremum is the derivative is all epsilon greater than, so there is A naught inside A such that this one is the definition, and you're trying to memorize some ways to do the problems, that is going to be a disaster, right? You cannot do that. Please don't do that. Okay, did you get this idea? Or if you don't get this one, I will explain it again, because this is the only real thing that I teach to you today, and also the definition for the infimum, because this type of definition will be used in uh, proving sequences as also in limits and everywhere. If you know how to understand this type of expression, you don't want to come any of these sessions, because you are done and you can do any real analysis one with pretty much easy. But if you don't know how to understand, you know how to visualize this statement, then you might need to work hard and need to visualize, and then you will be done. Okay, let me explain it again. I go to another slide and I'll just copy this one. I simply say something like, right? I simply say, I take my real number, right? I simply say something like this. I denote my S, right? I denote my S. And also, comma, and S is an upper bound, right? There should be some upper bound, right? Otherwise, this won't be true. Let's say S is some upper bound to your set. It means your set can be contained somewhere here, right? It means you can have anywhere, you can set off the element. You cannot have elements here, right? In the positive side, you can only have your elements in the negative side to your S. Then it is the mean by S is an upper bound. Then you say for any epsilon greater than 0, you can find some A naught in your set such that A naught plus epsilon greater than epsilon. It means if any epsilon, if you take A naught plus epsilon, it should lie somewhere here, not somewhere here. Assume for epsilon, to simply say, let's say 1, you cannot find an A naught such a way that A naught plus 1 greater than S. It means when epsilon is greater than epsilon is 1, because for all epsilon, you say if you take any positive number, you should be able to find A naught. Now I am saying, just assume if epsilon is 1, you cannot find a number in your set where when you add 1, it is greater than your supremum or your S value. It means if, let's say I assume let's say this is S minus 1. It means your all of your elements below that line, because if it is somewhere here, when you add 1, it will go into this side and it will become greater than your supremum, right? Because let's say for any, let's say S equals 10. So then if you have some element at least greater than 9, 9 plus 1 equals 10, right? If you have 9.1, it will be 10.1. Okay. So then, okay, then now it means if you put 1, you cannot find. It means all of your element you can say, because you cannot find this one, means your A for all A in your set A, this number should be greater than S minus 1. It means if you take A plus 1, it should be greater than or equal, less than or equal to your S. Because no matter what the number you take, you cannot find any number where A plus 1 greater than S. Because if it is happened, the statement is true. So then what would happen? S minus 1, this guy will become an upper bound. Simply, right? Because for some, let's say in this case for 1, we cannot find A plus 1 greater than S, means for all S, because we cannot find, let's say for all S, we cannot find A plus 1 greater than s. It means for all s, what should be happen? It should be less than or equal to s, right? Because that's the only thing we can happen if it is not greater than s. It means automatically s minus 1 become an upper bound if it is happen. It means we know this guy is smaller than s. So s cannot be supreme because we have an upper bound which is less than s. So then it is not the supreme. You get the idea, right? Simply, if you given some epsilon, you cannot find a naught less than a naught plus epsilon greater than s. Means for some a naught inside your set, means for all a naught inside your set, you should have a naught plus epsilon less than or equal to s and a naught less than or equal s minus epsilon. It means you will automatically have some upper bound below your s. So then your claim that it is, then it means your s is not your supreme. So this is what basically this expression explains as a whole. That simple idea. It will simply explain, if this is true, it is simply said you cannot find a smaller upper bound than s, so that s is your supreme. So that's what he's saying. So this is the mathematical expression. So if this is happens, definitely s is your supreme. Hello, fine. Anyone? Hello, anyone? Okay. Now we go into the other thing. I write down the other definition for the infimum, right? Infimum is, we denote this as INF of A, and mathematically we write the definition as L. Let's say infimum, we can write it as, typically we use, let's say, B or something. So we use S here, right? So let's say I is an lower bound, and for all epsilon greater than 0, there exists a naught in A such that a naught minus epsilon less than I. This double implies I is infimum of A, right? This simply means that if you take any positive number epsilon, if you can find some element in your set A, when you subtract that epsilon from that element, you will result in a number which is less than your capital I value. In fact, it means you cannot find a greater lower bound than your current existing I. Fine? Hello? Fine? Hello? It simply means, let's say you cannot find this one. Let's say for any, let's say some epsilon dash, you cannot find a naught such that an a such that in your set some that in this way, a minus epsilon dash less than I. It means for all a, in a it should hold that a minus epsilon dash greater than or equal to I. Okay, it means your a is greater than or equal to I plus epsilon dash. So this is greater than your I, right? And it is itself become a lower bound, because in every element in your set will become greater than that value if you cannot find a value where when you subtract epsilon dash from that value, which result a number less than I. This simply mean that what? This simply mean that your infimum is your largest lower bound. You cannot find any larger lower bound than that. Simply, if you take the set, this is the this is, you can push your lower bound at max. You cannot have some, it is somewhere here. That is simply it means. So in real analysis, this visualization is the important. Don't focus on memorizing these what you call quantizers or like quantifiers or any of these definitions without knowing this intuition. සිංහලෙන් කියනවා නම් අර වෙන දේ පොඩ්ඩක් එකට දැනගන්න නැතුව නිකන් ඔය definitions ටික අරන් කඩපාඩම් කරගන්න එපා. එහෙම කරොත් නම් කෙලවෙනවා. සරලවම කෙලවෙනවා. හැබැයි ඔය අයිඩියා එක ඔලුවට දාගත්තොත් ඔතනින් එහාට ඔයගොල්ලෝ ගොඩ තමයි මේක ලයිව් එකේ ඉන්න කියන්නේත් ඒකයි. මොකද කියන්නේ ඕගලන්ට සාමාන්‍ය මම කැමති ප්‍රශ්න අහනවා නම් මොකද ගොඩක් වෙලාවට ඔක එකපාරට තේරෙන්නේ නැහැ. මම දන්න ඔක 100 ටැමිල් වගේ. තමයි මට බය වෙන්නත් ඇති මෙතන. මේක මොනවා කියනවද දැන් මේ තේරෙන්නේ නැහැ. හැබැයි ඇත්ත කතාව මේක තේරුම් ගන්න ටිකක් අමාරුයි. මොකද අපි ඒ level කාලේ මෙහෙම දේවල් අපි ඉගෙනගෙන නැහැ. සහ ලංකාවේ තියෙන education system එකත් එක්ක මෙහෙම අපිට පොඩි කාලේ දැන් මැත්ස් වල හිතන්න උගන්වලත් නැහැ. කියන්නේ සාමාන්‍ය මෙතන ඉන්න අය මම හිතන්න බෑ කියන එක නෙමෙයි. මෙතන ඉන්න ඇත්තටම ලංකාවේ ඉන්න දක්ෂ මැත්ස් කරපු අය. නමුත් ලංකාවේ තියෙන යම් හෝ වැරද්දක් නිසා අපිට පොඩි කාලේ දැන් මැත්ස් උගන්වන්න විදිහ යම් කිසි වැරද්දක් තියෙනවා. ඒකයි අපිට කැම්පස් එකට ආවට පස්සේ ලොකු වෙනසක් තේරෙන්නේ A level mathematics එකේ යුනිවර්සිටි level mathematics එකේ. මේක පැහැදිලිද? හෙලෝ. පැහැදිලි? හරි. හරි. දැන් මම මෙහෙම දෙයක් කියනවා. right. ඕක මම කිව්වට පස්සේ ඔප්පු කිරීමකට එන්න නැතුව මම මෙහෙම දෙයක් කියනවා. මම නිකන් සරලවම දැන් මේ කිව්ව දේ තේරෙනවද කියලා. දැන් බලන්න. මම ඩෙෆිනිෂන් එක ලියන්න නැතුව ගානක් විතර ලියන්න නැතුව මම වෙන් රූපයක් හදනවා. මේ තියෙන්නේ මගේ A කියලා සෙට් එක. මේ තියෙන්නේ මගේ B කියලා සෙට් එක. හරිනේ. මම ඔයගොල්ලන්ගෙන් අහනවා ඔයගොල්ලෝ ගත්තොත් supremum of A කියන එක්කෙනයි supremum of B කියන එක්කෙනයි. ඒ වගේම infimum of A කියන එක්කෙනයි infimum of B කියන එක්කෙනයි. මේ හතර දෙනාව ගත්තොත් මට කියන්නේ මේ දෙන්න අපි වෙන වෙනම ගමු. මෙයා number 1 මෙයා number 2. මේ දෙන්න අතර තියෙන රිලේෂන්ෂිප් එක මොන වගේ වෙන්න ඕනද? අපි ඉස්සෙල්ලා supremum එක ගැන කතා කරමුකෝ. If you take two sets, let's say A and B, B is completely resided in A, and then you take this when you take supremum A and supremum B and infimum A and infimum B. Can you please one of you guys tell what should be the relation between supremum A and supremum B? Whether supremum A is larger or supremum B is larger, or will they equal? What are the possibilities? Or it has no relationship. That is also possible answer that you can give. Can anyone? I like if you can unmute and tell. Hello.
Supremum A is large.
Supremum A is large. Why? Why? Now I am asking why. Huh? What? Actually, I don't think, I didn't hear clearly. What is the reason? Yeah.
Large වෙන්නත් පුළුවන් supremum B එකට සමාන වෙන්නත් පුළුවන්. ඒ කියන්නේ set එකේ
Yeah. So I think I have the answer in the chat, and also you did also correctly. But that's the nice way you were thinking about. That's a pretty much correct answer. Actually, this should be something like this. It means supremum B technically means the largest upper bound that set B can take, right? In this set, right? Largest upper bound that this set can take. Let's see if you draw the real number line. Sorry, I lost the connection. Can you hear me properly? Hello? Can you hear me?
yeah you can hear.
Okay. So if you take supremum A and supremum B, you know the supremum B is the smallest upper bound that can have for set B. Supremum A means the largest upper bound that set A can have. Let's draw this. If your supremum B here, it means all of your B elements should be here. We should be somewhere below that line. But this set A, intuition we know that can have element which don't set B don't have, right? Simply A can have more elements than set B. It means there's no restriction to set A to go here. If the supremum A can be here as well. Because the only restriction is all of the elements in B should contain set A. So if you have the supremum A here, it is already satisfied because supremum A can be become upper bound, and you can have some elements here to make it the supremum larger than supremum A. And also, this infimum can go it like this one. So you can have the infimum of B if you draw in the same way, right? Let's say this is infimum of B. So you can have infimum A here. In other words, I draw it in another way. If you take real number here, you can have supremum A here, and you can have infimum of A here. Because you know your set B, sorry, supremum B, yeah, the supremum A and infimum A. Okay, so you know your B is the set B should be smaller in range than set A because it has fewer elements. It means it should have something like this, right? Supremum of B. It cannot have its infimum here, and it cannot have supremum of B here because the set B should constrain, we call it constraint or limit tightly than the set A. සිංහලෙන් කියනවා නම් set B ගේ සීමාව B කියන set එකේ සීමාව ගොඩක් පොඩි එකක් වෙන්න ඕනේ A එක්කෙනාට වඩා. මොකද A එක්කෙනාගේ සීමාවෙන් එළියට B ට යන්න බෑ. කියන්නේ ඔයාගේ ඉන්ෆිමම් එක මේ වගේ තැනකට යනවා කියන්නේ A ගේ නැති එලිමන්ට් එකක් B ගේ තියෙනවා කියන එක. එහෙම වෙන්න බෑ. ඔයාගේ සුප්‍රීමම් එක මෙහෙට යනවා කියන්නේ A ගේ නැති එලිමන්ට් එකක් B ගේ එනවා කියන එක. එහෙම වෙන්න බෑ. පැහැදිලි? හෙලෝ. පැහැදිලිද? Okay. Right. ඕක තමයි අතර සුප්‍රීමම් සහ ඉන්කම් ගැන ඩෙෆිනිෂන් තියෙන. ඊට පස්සේ අපි තව මේකෙන් තව ගණන් ටිකක් ඉස්සරහට කළා. දැන් මෙතනින් ඉස්සරහට ඇත්තටම මම ඊළඟට කරන්න ඉන්නේ සුප්‍රීමම් ඉන්කම් සහ මේ concepts වල ගණන් හදන එක සහ එතනින් එහාට ඊට පස්සේ මම ඊළඟ සෙෂන් එකේ ගොඩක් දුරට limit starts කරනවා real analysis වල. So when we continue in these sessions, actually what I'm going to do in next session is actually I'm going to do some more problems on these concepts and to start limits in the next session. So because there are a couple of videos in online as well, but before going to that one, I need to give you some proper understanding step by step. I need to build you up a level where you can understand these concepts. I know it is a one shot you cannot do, and also I will share you some references as well. And okay, so before winding up, I have some couple of more announcements to give. So I think we are in the university. I think I should tell you these things beforehand because when you're in the university, it is not a like competition, right? You don't want to actually it is not a competition with others. It is always a competition with you, and also it is all about collaboration. So don't try to win it as an individual. So you need to make it as a team and help each other. And if you know something, always teach to other and help people. That's where you can actually develop in university life. Otherwise, you cannot develop and you will fail as a batch, right? So don't do that one. Help each other. And if you know something, always teach others. And also, if you don't know something, don't hesitate to ask someone else. And also, if you need any help, you can always ask me. That's always one thing. And also inside the university, you should develop two things. One is skill and knowledge, that is that you can develop using the modules and exams, getting good grades. That is one thing. The other thing is the personality. It means if you don't develop your personality, it means if you don't help you out, it means there are a lot of I think extracurricular activities available, the Rotaracts, ISACs, and sports and all or sports and others, and also there are a lot of charity works. So don't say like that if you invite some charity work, I have an exams and so on. I don't saying that without attending exams, go to those charity works, but keep in mind that allocate some of your time to charity works to help the people in Sri Lanka. This is not a political talk because you learn from free education, so you all have responsibility to help people because there are a lot of schools where are no teachers and no pretty much difficulties they are facing even inside the Colombo. So it is your duty, and it is what you call it is actually we all have to do that part because even me and you. So reach out and try to do something to those kids as well because if you know if one of these guys change their mind and come to the university, the whole life of their family changes, right? But it is actually eventually what is going to happen to your families after 3 to 4 years time. So keep in that mind because when you do that, those things come in unexpected ways. Because I'm saying that I have 4.0 GPA, right? I have 4.2 overall GPA, and I have conducted seminars in more than 15 schools, and I conducted programs in I think more than 25 times in my own school, and I think this is the sixth batch I'm conducting cookies. So if those things doesn't like degrade your academics, so decrease your results, I'm the first one to repeat and I'm the first one to fail. So it is not a thing like that one. So also, and in next week's or next sessions, I will try to keep the sessions around 1.5 hours, because I know keeping the things long, you will feel tired. I know 2 hour lectures, even it is online or physical lectures, is difficult. So if you have any problem, please don't hesitate to reach me out via Telegram or WhatsApp. I prefer WhatsApp. I will share my contact number with you all via Telegram as well. In WhatsApp, you have my number. So yeah, that's it. So I will wind up this session. So if you have any feedback, don't hesitate to send it to me via WhatsApp PM. And if you have, it doesn't matter like scoring that. It means ඒ කියන්නේ ෆීඩ්බැක් එකක් තියෙනවා නම් කියන වේගෙ වැඩි නම් තේරෙන්නේ නැත්නම් බයින්න හරි අමතක කරන්න එපා. මොකද මට ඒතර ඊළඟ ටිකේ ඒ ටික හදා ගන්න පුළුවන්. ඒ වගේම තව මොනවාරි ඇඩ් වෙන්න දේවල් ටිකක් තියෙනවා. ඔයගොල්ලන්ට ස්පෙસિෆිකලි කවර් වෙන්න ඕන කන්ටෙන්ට් එකක් තියෙනවා. ස්පෙસિෆික් 21st batch එකේ අයට කියන්න මම මේක ඉස්සරහට කන්ටෙන්ට් එකක් හදා ගන්නම්. අද මට බේසිකලි ඕන උනේ රියල් ඇනලිසිස් කරන බේසික් ඉන්ට්‍රොඩක්ෂන් එකක් දෙන්න සහ ප්‍රැක්ටිකලි පොඩ්ඩක් ඔයගොල්ලන්ට තේරුම් ගන්න පුළුවන් තැනකින් පොඩ්ඩක් රියල් ඇනලිසිස් වල පොඩි ස්ටාර්ට් එකක් කරන් දෙන්න. ඒකයි ඉන්ටර්වල්ස් වලම සුප්‍රීම සහ ඉන්ෆියම් කියන දෙක වෙනකන් කරේ. ඔය concept එකෙන් පස්සේ ඊළඟ සතිය අපි ඉස්සරහා පාඩම් වලට යමු. එහෙනම් thank you හැමෝටම. මොනවාරි ප්‍රශ්න තියෙනවනම් අහන්න පුළුවන්. හෝ ඩිස්කස් කරන්න තියෙනවනම් is the supremum of a set equal to the set's maximum? No. Sometimes it doesn't. Right? In an open set, supremum doesn't equal to the maximum value because you don't have a maximum value inside the set when set is open. So simply the answer is no. It is simply the smallest upper bound that you can take. Same goes with the infimum. Okay, if you have any problem, you can ask. Python session එක next Sunday තමයි කරන්න ඉන්නේ. අපි කරන්න ඉන්නේ. එතකොට අයියා Python session ඕගලන්ට කරයි. ඕගලන්ට එහෙම වෙන free available දවසක් තියෙනවා නම් මට ඕනනම් කියන වෙන දවසක් ඕගලන්ට දාලා දෙන්න පුළුවන්. මම කැමති නැහැ සතියට දවස් දෙකක් විතර ඕගොල්ලන්ට මේ වෙන මට නම් ප්‍රශ්න නැහැ. සතිය දවස් පහම කරලා උගන්න දෙකට එක දවසනේ. නමුත් ඕගොල්ලන්ට එහෙම හැකියාවක් තියෙනවා නම් කියන්න. එහෙම වෙන දවසක් වුණත් arrange කරලා දෙන්න පුළුවන්. ප්‍රශ්නයක් නෑ. දැනට හිතන් ඉන්නේ මම සතියක් කර සතියක් Python maths වෙනවා මාරු මාරුට යනවා. STEAM is such that S.team is such that right? කියන්නේ short form එකේ such that කියන එක අපි short form ලියන්නේ ST එකේ. anyone? මම board dash කරන මේක කාලේ තමයි මේ ST කෙනෙක් කියන්නේ මොකක්ද කියලා මම හිතන්නද මම අර මෙතන දාපු නිසා වෙන්නේ නැති. STEAM is simply such that, right? Such that. තමරට තියෙනවා අහන්න පුළුවන්. Yes, I will discuss past papers, and if you have any tutorials, please send it to me. But keep in mind that don't send me the assignments that graded, right? That are graded. So don't send me those. And tutorials, yes, you can send. I can do more sequence or remand. I will do in next sessions. Can you do my sequence or remand equation that will get if I show some example. Okay, so yeah, I will do more in sequences, because before we going into the sequences and remand, we need to cover limit, because that's a basic building block into the sequences and series, and also in remand. So we need to cover limit first. So I cover limit first, then we can do into the sessions. So because before you go into this stuff, to get the basic idea, you need to understand what are the limits and how you can deal with the definitions and how I doing the inequalities and so on. So basically that are things you need to learn, because in Riemann also you have this kind of like supremum and infimum thing when you come into the upper Riemann sum and lower Riemann sum. So and also you have some other things in sequences and also in series that will be like dealing with inequalities. So I will cover in that next session the inequalities and the triangle inequalities and how you can use that one, because those are the things using in the proofs most of the time. Any other questions? Hello. If there is no any other problem, I will wind up. Is there any way of accessing the slides you have written? Yeah, I will show us. Yeah. Can
රෙකොඩින් එකක් දානවා
recording එක මම මේ උනාට පස්සේ upload කරන්න YouTube එකට ඕ Google Drive එකට මම ඒක upload කරලා ඔයගලන්ට එවන්නම්. That is one thing, and also someone asked, can you go? No, yes, I will share the PDF. Yeah, sorry about my handwriting because I know it is bad, but nothing to do, right? So that's the best I can write because even I think, yeah. So I don't think 13 years of my school life. QC, eh? QC means I think Q means rational numbers, not QC. This Q basically we put something here, right? Q and we put some like bar here to indicate just the rational numbers. That's why we write Q. QC, it means irrational numbers, right? Q's complement. C implement for complements. That's right. Sometimes we note as QC, it means the complement. Complement means because the whole set is real numbers, so one set is Q and other set is Q's complement. It is simply as A inverse, right? It means the inverse set, or it means the other real numbers that are not rational numbers. That's actually C means. It is actually a matter of notation. I think you got the answer, right? Any question? I will show you a book with real analysis questions and answers. Today I have the book. I will show it to you. Let me share the screen to you. I think. Oh, yeah. So here actually you can have this actually. No, this book that I shown here. So this actually problem book in mathematics. So you can actually have basic fundamentals of, we have real numbers section here. Actually it is enough, and also sequences things here. For some reason I think some pages are not showing up. I don't know why. So I will see. Previously it is shown, but I will work out and see why it is happening, and I will show it to this book with you. It is actually problem books in mathematics. I will share you the books. There is ISBN number. I will share you another copy or some link to download the file. I will share it to you. That's definitely. So okay, so seems like there are no any problems. So you can always contact me, and also he said if you see me, you can contact me. I think I'm pretty much different than the DPs look like. So because it is pretty much a photo shoot thing, so I'm not like handy like that. But if you see someone like me, just ask you if you are solution, and then you can talk with me. So then that's it. So I will wind up the today's session. For next week, there will be a Python session, and week after next week, I will continue from these two analysis sessions, and I will share the recording as soon as it is prepared and converted. Thank you all.